All right, so let's think about the different types of intermolecular forces. So the first one we have here are dispersion forces, or sometimes called London dispersion forces. You can include the London or you can not include the London. It's up to you. In general, London dispersion forces are the weakest, but they're also the most common because all matter experiences it. So everything has dispersion forces. And so what it is, it's caused by a random temporary instantaneous dipole, which causes nearby attractive induced dipoles. So a lot of big words, looks confusing, but it's really not too bad at all. So let's take a look at two atoms next to each other. So we've got our positively charged nucleus, and then around it we've got kind of this cloud of electrons, and then we've got another one right next to it. And we'll say both of these atoms are neutral. So what happens is these electrons are constantly flying around the atom. And so since they're constantly flying around the atom, they're not always in the same position. And so at any one moment, the electrons could randomly move to one side of the molecule. And so this is what's known as a temporary dipole. Right, so all of these electrons are moving out and about, and it just so happens that at this one moment, all four of these electrons are at this one side of the atom. Meanwhile, the other atom is relatively unchanged. Well, you can see that we have a dipole here, right? We have a positive end and a negative end on this dipole. And so there's going to be attractions and repulsions with neighboring atoms, right? This nucleus is going to attract these electrons, right? It's going to pull them closer to each other. And so what this temporary dipole is doing is it's inducing a dipole on a neighboring atom. Right, so if you think about the way this is going to look after these attractions play out, right, this nucleus has now attracted all of the electrons closer to it, right? And so we have a dipole here, and we have a dipole here, and so there's an attraction between the positive and negative end of this dipole. And so this positive negative attraction is the intermolecular force known as an LDF, or just a dispersion force. Right, so there's the steps for it. It starts, everything has it, right, because all matter has kind of a proton and electrons, and it's caused by this temporary dipole, which then induces another dipole and causes an attraction. And so here's the same picture, just kind of redrawn. Right, you can see at one point we have a dipole, an instantaneous dipole, and then this instantaneous dipole induces further dipoles and thus causes more attraction.